What's up guys, Patrick here, welcome back. And in this video, what we got to do is got to find this limit here. The limit as x approaches 0 from the positive side of sine of 5x over root x sine 3 root x. And notice that we got to approach it from the positive side. I want to make a note on that because we can't be approaching this from the negative side because we have this root x here and here. So the domain of both of those parts has to be greater than 0. And it can't be equal to 0 because then this whole denominator would be 0. So that's actually the next point. You can't make a direct substitution in this case because you'd have 0 over 0. It would be an indeterminate form. So we're going to have to use another strategy, but just wanted to make a note that this has to be positive, right? You can't just be approaching 0 in general or 0 from the negative side. You got to be approaching it from the positive side because of these square roots. So notice that this here, let me just rewrite it here. This is actually going to be a trig limit type of question. Hopefully you went through the lecture videos on trig limits, as there's a bunch there. And I feel like the questions in the lecture videos get a little bit more complex than this one at times. But if you watch those lecture videos, basically what we're going to be doing is we're going to be using the property. Hopefully you could tell by this point that as infinity approaches, or theta approaches 0 of sine theta over theta, we know that that's going to equal 1. It's like a fundamental trig limit that we're going to use to solve this. But notice we're not just approaching 0, we're actually going to be approaching 0 from the positive side. And so we can actually rewrite this as well as the limit as infinity approaches 0 from the positive side. Now, why can we do that? Well, because if we know the limit as theta approaches 0, let's say of some kind of function, equals 1, well, what that means is that the limit as theta approaches 0 from the negative side equals the limit as theta approaches 0 from the positive side of that function, which is equal to 1. So if we know this, then automatically this holds right here. So just wanted to make a note of that as well. Kind of cover all my bases here before we get into the explanation. So because this holds, and I'm going to be using this because we got 0 approaching from the positive side here. Okay, so what we do here, what we want to do is try to get this in these kinds of expressions. So basically we need to have an expression. These two expressions have to be the same. In this case, they're just variables, but they could be any expression. Okay, so what we're going to do here is we're going to rewrite this. Actually, you know what? Let's do it up here. What we're going to do is, notice we got this expression 5x here. So we want to get a 5x at the bottom. But we can't just add a 5x to this expression, right? We got to add 1 at the top as well. To keep this expression the same, we're going to be like multiplying this by 1. This is just 1. It's just we're adding more to it now. And then notice this expression, 3 root x, we want to put that at the top. But you can't just add something to the top, you got to add it to the bottom as well. So I'm taking this expression, multiplying it by this, and then multiplying it by this as well. So what I'm going to do is I'm going to sort of combine these in a nice way where we can work with them. So I'm going to combine this and this. So I'm going to rewrite sine of 5x over 5x. So these go away. I'm going to combine this and this. So this and this go away. And then I'm going to combine this 5x is left. And then we got this 3 root x, and then we got this root x over here. Like that. And then notice here, what's this going to simplify to? Notice root x times root x is just x. And so this x and these would cancel out because you'd end up having x over x. So you're just left with this constant here, 5 over 3. So what I'm going to do in the next line is I'm actually going to take this constant out. We're using properties of limits now. And then we got these two functions that are multiplying by each other. So I'm going to take this limit and sort of quote unquote distribute it to this and that. So we'll have the limit as x approaches 0 from the positive side of sine 5x over 5x. And then we'll have the limit as x approaches 0 from the positive side of 3 root x over sine 3 root x, like that. So we got this, and we got that, like that. Okay, and now what I'm going to do, let me erase all this, is I'm actually going to just work with these two limits separately. So I'm going to first rewrite this. So this is sort of work on the side here. Limit as x approaches 0 of sine 5x over 5x, like that. And notice that we can make a substitution here. We can let theta equal 5x, right? So we're going to plug in theta here, but then we got to plug in something here. So what happens as x approaches 0 from the positive side? Well, notice that theta is going to approach 0 from the positive side. If we take 5x and graph it, goes through the origin. Right, it looks like this. As x approaches 0 from the positive side, the y values are approaching 0 from the positive side as well. So we could take this, knowing this, and rewrite it as the limit as theta approaches 0 from the positive side of sine theta over theta, which we know is equal to 1. So this bracket here ends up being 1, like that. And now I'm going to work with this limit over here. So we have the limit as x approaches 0 from the positive side of 3 root x over sine of 3 root x, like that. And so again, I'm going to do a change of variable here. So I'm going to let theta equal 3 root x. How does this look like? Well, 3 root x, it basically looks like that. So what happens as x approaches 0 from the positive side? Well, as x approaches 0, notice the y values are approaching 0 from the positive side as well. Okay, so we can do a substitution now. So basically, we would rewrite this as the limit as theta approaches 0 from the positive side, right? We're subbing in this for that. And then we're subbing in theta for 3 root x and 3 root x here. So we would have theta over sine theta. Now, if you remember from the trig limit lecture videos, this is basically just equal to 1. But notice that if you want to show the work a little bit more, it's not in this format. But what we can do is we can actually rewrite this like that. Okay, because if we have a fraction, a over b, that's the same as 1 over the reciprocal of that fraction. So that's what I did here. Took this fraction 1 over the reciprocal of it. And then what we can do, let me kind of split these up here. I'm going to continue this over here. So what we can do now is properties of limits. So I can take this limit, put it in the numerator. I could take this limit, put in the denominator. So I know this is kind of like over the top of showing work, but just want to break everything down properly. So limit as a variable approaches something of a constant, it's just that constant, and then this we know is equal to 1. So the whole thing is going to be 1. So the limit of this with all of that work is equal to 1. So this here ends up being 1. 5 over 3 times 1 times 1. That just ends up being 5 over 3, like that. Right? So this here is the final answer for that limit right there. And if you're a little bit hesitant with trig limits and how they work, highly recommend you go back to the lecture videos and watch that section. I have a bunch of examples.